So we're now up to 37. And 37 has this case, adverse effects of tobacco and alcohol and tobacco. The table lists some common adverse effects of prolonged tobacco and alcohol use. So for tobacco, we have emphysema, heart damage, and cancer, which we abbreviate with E, H, and C. And for alcohol, we have liver damage, brain damage, and heart damage, L, B, and H. So we have one common thing, which is heart damage. And it says, let T be the set of the listed effects of tobacco, and A be the set of listed effects of alcohol. So let's go ahead and what are we doing next? 37. Okay. So I might be able to use this for the next two. So we're going to call T be the set of the effects of tobacco, which I'm going to put them in alphabetical order. C, E, and H. And alcohol, what did they use? A. That's what I figured. That's what I would have used. And again, in alphabetical order, we have B, H, and L. Okay. The smallest possible universal set U that includes all the effects listed. So the universal set will include the union of these two. So the universal set is equal to the union of A and T. And what we get from that is we get everything. So we get B, C, E, H, and L. L is the common one between the two. And you know, you don't have to do them alphabetical order. I just did alphabetical order. Okay, 40 is what is the intersection of T and A. And so the intersection is where you have the same term. So the same term, or terms, in this case it's only one term, is heart disease. That's the common term between the two. Okay, we're going to skip on to 49 now. Assuming that A and B represent any two sets, identify each statement as either always true or not always true. Okay. So what do we have here? We have A is a subset. I can't remember whether that's the proper subset or the just regular subset, so I have to go back and look at the book here. I think it's just a subset. So let's look here. I guess subsets were in the previous section. So subset is the little thing on the side with a line underneath of it. A proper subset just has to have, it can be the same as the other set, or it can have less elements. So if you have the A is a subset of A union B, well, that's going to be true. That's always true because if you have the union of these two, you're going to have everything in A plus whatever's in B that's not in A. And so this is always going to have more elements than A. So this is always true. Okay, the next one is 52. And here we have the intersection of the union of A and B is a subset of A. Okay. So this is actually, the only time this will actually be true is if B is a subset of A. So that when you do this, you just end up with A, and then A is a subset of A. But all other cases, if there's any elements in B that are not in A, it goes the wrong direction. So it's kind of like this one, except it's the other direction. So this is not always true, but it's not always false either. There is a case. Not always true. So let me give you an example there. Let's say A is A, B, C, D, and B is C and D. So when you take the union of these two, the union of A and B, you just get A again. And so then if you say is A, B, C, D a subset of A, B, C, D? Well, the answer is yes. It's not a proper subset because a proper subset would have less entries than this. They'd still be in here, but they would be less. Okay, what do we got next? 56. Exercise 55 through 60. Use your results in part A and B to answer part C. What does, let's see, how many do we have here? 50, 55, 56, 59. Okay, yeah, let's go ahead and do this. So the universal set is 1, 2, 3, 4, 5. X is a subset of that, which is 1, 3, and 5. Y is another subset, which is 1, 2, 3. And Z is another subset, which is 3, 4, and 5. Okay, so what are they asking us? Find the union of, so A56A, find X intersected with Y. So we look for common terms, and we have 1 and 3 are the two common terms. So the intersection of X and Y are 1 and 3. 2's not in here, and 5's not in there. The next thing we have is Y union X, Y intersect X. And actually, this is exactly the same thing. It doesn't matter the order when you have an intersection or a union, I guess. So it's still 1, 3. And then the question is, state a conjecture. Okay, well, the conjecture is just what I said, is that the intersection of X and Y is equal to the intersection of Y and X. And remember, back to the reasoning, is that a conjecture is, you look at 2 data points in this case. We did 2 cases, X, and it was particular examples. It wasn't every set, possible set that you could ever think of. It was these particular sets. And we showed that with these particular sets, that X intersected Y because Y intersects X. So from that observation, and because they're equal to each other, we could make that conjecture. Now, is that always true? We don't know. We just know for this particular example, it's true. Now, if you were, there's probably some mathematical proof that would tell you one way or the other. And so now we have 59, which is the second case. So A is find the complement, let's see, X in union with Y, take the complement. So what do we have? X union with Y is going to be equal to, let's do that, X union with Y. It's going to be 1, 2, 3, and 5. So it's everything that's in here plus everything that's in there, and if we have common ones, we just rewrite it one time. So we have 1 in both places, 2 in one place, 3 in 2 places, 5 in the other. So that's the union. And if we take the complement of that, that relates to the universal set. So if we take the complement of this union, so the complement of this is going to be everything that's in the universal set that's not in that. So all we have left is 4. 4 is the only element in the universal set that's not in that particular set. Okay, so that's A. B is actually where you take the complements and then union. So you take X complement union with Y complement. So it's kind of like the distributive property. Can you distribute that to each individual term? So we have to do X prime And X prime is everything that's in the universal set, but not in this. So it's going to be 2 and 4, because we don't have 2 and 4 in there. And Y prime is everything that's in here, but not in there. So that's 4 and 5. So now if we take X prime union with Y prime, actually, this is intersection, isn't it? Okay, so this is the intersection. So the question is, if you take X union with Y, take the complement, is that the same as the complement of X intersected with the complement of Y? So let's make sure we fix that. And so when we intersect it, we find that if there's any common terms, which there is only one, which is 4. So the conjecture in this case is that X union with Y, take the complement of that set, is equal to X complement intersected with Y complement. So that's the conjecture. I don't know whether it's true or not, but it's, for that particular case, it is. Okay, so we're going to stop to there.